this one. So here in the vicinity map, so students will be making a vicinity map where it shows the view where the student reside and where does the school could be found. As the paths are being created in the map, students should be able to show the following. All right, so here are the following that you should be showing. No, so graph of the whole plane showing the following. First, the legend. Do not forget the legends. All right, so in making such maps, there should always be a legend. All right, so the legend that represents the points in the map. All right. So the measure units of distance which could be found at the axis of the map. All right. So um the points you could simply point a location. For example, you will be pointing your house and the school could be, and as well as some places. For example, Alpha Mart, you will be pointing that one, no? You will make a point. And what else? What else? What do you call this one? In the Talisay, do you know the Talisay? There's a tricycle. You could point that one so that we could know. This is yeah. So that we could know on what path are you in your map already. No, you couldn't just make a path somewhere down the road. No, so also point of location from their house to the school. That's the one that I'm saying. And the distance of the path from their home to school as its lines in a plane. All right. So for this one, yesterday we discussed distance formula. No. So I hope you get or if you are still having a hard time with that one. Yeah, I am open. You could have a group session if ever you want to request. I will be giving you my time really. No, if you have that uh, encouragement for yourself and for your companions, you could ask me, no? You could request for the distance, no? And also the midpoint of line segments joining 2 points, no? So midpoints will be discussed maybe on Friday, no? So it is really important. Right, there you go. So it is really important for us to attend that meeting as well, no? Alright. So okay, so aside from the distance, the midpoint should be also shown there. This is Rodrigo. So alright, so for that one, distance and midpoint, no. Aside from that one, we also have the total unit distance of their arrival from their home to school. How is that one? The distance, alright, please wait. Distance, alright, and the total unit distance. If we say total unit distance, for example, you could uh, have a unit, for example, from Alpha Mart in our school up to Talisay. It's up to you if you want to make it meters, as long as all units are in meters. All right. So all points, for example, in your paper, no, you will be measuring that one in centimeters. So all measures should be in centimeters, and all paths should be sum up. Okay, that's why it is total unit distance. So each path should be sum up. All right, so it is different. Two things. There are two different things. The first thing is for the distance where you could find the distance within 2 points. You know it already, the one that I discussed yesterday, and the total unit distance from your house up to the school. It's up to you on how are you going to make your path much easier. But I want to see that uh, the computations, you know it already, and um, measurements as well. Because you will be doing this one in this part. No, the vicinity map should be eye-catching for those who will be the map reader. No, creativity and uniqueness of the map should be applied. This vicinity map is expected to be received in a physical form. But in this case, this the case, no, you will be making your vicinity map um, could be in short bond paper. So if you will notice, it is really small, right? So the one that we used to have is the large ones, that is vicinity map. But in our case, we really don't allow, students going in our school unless that there are some kinds of, for example, the eye checkup, So the one that we are going to do is to make your vicinity map either, all right, either in long band so that it could be enlarged, compared to the short band paper. You could make your vicinity map in long band, long band paper. Then after you draw with your ruler and such, you could put it, you could scan it. You scan it properly, so that once I print it out to my bond paper, I could know how long is the distance because I will measure it that one. Was it clear? Is it clear? All right. So measurement is uh, applicable for me still, no. How I am going to measure. In case that you make it on Longman River, please scan, ha. If you don't have scanner, go to somewhere else, or you could ask somebody to scan your work. All right. So also there are such apps, no, such apps that uh, for example, in cell phone, they could scan your work and you could put it in Word. And in case you are having a trouble, you could try to print that one so that whenever it is printed by somebody else, or you tried it already, that whenever it was printed, it is being printed, the measurement are just the same. All right? Are we clear with that one? Grade 10. All right. I don't want to hear like, sir, you didn't discuss or whatever. If you have questions, if you have queries, you're having troubles with this one, you could ask me, huh? Alright? You could ask me. Okay? Alright, so I hope the theta for calculus is now clear, and I will be presenting now our discussion for advanced math. Please, sir. Alright, so before we proceed to our next lesson, I would like to ask for this class, no? So, what is our last topic, no? Last topic in our advanced math. Would anybody wants to answer? Would anybody wants to share their thoughts? What are the things that we discussed in our past meeting? Jake, would you mind to share? Do you remember something with our past discussion with regards to advanced math?
Sir, about the last topic, it was about the formula to find the sum of an arithmetic sequence.
Alright, so arithmetic sequence. Are you sure it is arithmetic sequence? Hmm. Right. So we used to have the sum, no? If we tend, or listen, grade 10. We have arithmetic sequence, right? So at the first part of our meeting, no, we discussed what's the difference between sequence and series, no? In arithmetic sequence, if you will notice, no, we discussed things on how to get the nth term, right? As well as uh, what do you call this one, the common difference, right? But when the time that we go to arithmetic series, no, we tend to have arithmetic series when we get the sum of all terms. All right, so take note of that one. No, we tend to have arithmetic series if we tend to get the sum of the whole terms in the sequence. No, so the arithmetic progression or arithmetic sequence, one thing in mind, Grayton, if you heard arithmetic sequence, it is just the same with arithmetic progression, no? Because if we have sequence, no, we define sequence as also a progression of terms or numbers. All right. All right. So, with regards to that one, yes, we discussed uh, arithmetic series, right? So arithmetic series. And do you remember the summation notation? Summation notation? Would you mind to tell me what's the formula of summation notation? Right then, go. Would anybody would like to answer? Zyril, go. Hmm. Go, Zyril. The formula of the summation notation. Go. Hmm. Would anybody would like to answer? Anna, Regina. Go, go, go. How about the others? Dental Cruz. Hmm.
Sir, may
Yes, you may.
sige, sir. Sn is equals to a1 plus an over 2 times n.
Alright, so that is correct. No, SN or summation notation. Alright, so I will accept that one. No? So it is right that we have the formula of, I will be writing this one. No? We have the formula of Sn or S, this way. S is equal to A sub 1, alright, plus A sub, A sub N, no? A sub N, all over what? All over 2, alright, times n, or we could put n here, no? Alright, so that is correct, no? So, from this series that we discussed, no, let us now, thank you for that one, Abigail. Alright, so, for this arithmetic sequence and series, no, I want you to remember what are the things that we discussed right there, because we are now to enter with regards to geometric sequence and series. All right, so from this class, if you will remember, no, how do we define sequence in series in terms of geometric? How would anybody would like to answer? Nathaniel.
Sir, can you repeat po the question? I
Again,
missed that.
yes po. So again, if we discuss arithmetic and sequence and series, right? So from those things, no, we are to tackle na the sequence and series of geometric. So how last time, no, we also somewhat view what is geometric sequence. So how would you define or how would you tell if a sequence and
Um,
series is geometric?
Geometric sequences po have a common ratio which is usually characterized po by multiply or divide po.
All right, so that's correct. So thank you for that one, Nathaniel. So we define geometric sequence and series if uh, it has common ratio. No, if a sequence has common ratio and not common difference, we define it as geometric sequence and series. No, all right. So we have this. We discussed this one already. No, about infinite sequence. No, so if we talk about infinite sequences. If infinite sequence, no, it is a function whose domain is a set of positive integers. If you say positive integers, of course positive, no, there's no negative. All right. So let us have these terms. No, we have a sub one, a sub two, a sub three, up until the end. Those are the things what we call as terms. All right. So if you will remember, no, we have the formula or general term. If you will remember in arithmetic, arithmetic sequence, no? So we have, in order for us to know what is a sub 1, if you will remember, a sub 1 plus, I'm sorry. Alright, so if you will remember, no, in order for us to know what is a sub 1, a sub 2, a sub 3, alright, so a sub 4, alright, so if you will remember how to get a sub 1, simply have a sub 1, right? So about a sub 2, we tend to have a sub 2 with the formula of a sub 1 plus the difference, right? While in a sub 3, we tend to have a sub 3 when a sub 1 plus 2 times d. Do you remember that one? So these terms are seen as a general term. Alright, so if you say general term, it is general term is used in order for us to know what is the term. No? For example, the term here is a sub 2. Mm. Without getting the difference, or I'm sorry, without having that this term, no? So how are we going to know if you have the given of a sub 1 and the difference? Without having, or for example, let us have a sub 1, uh, blank, blank, no? And blank, then, for example, uh, a sub 1, 2, 3, 4, a sub 5. But you have the givens of a sub 1 is equal to 5. The uh, difference is 4. So in this place, you could have 5, no? 5. Then the common difference, you just not simply add, no? But if you are to find, for example, a sub 9, what are you going to have is a sub 9 is equal to a sub 1 plus 8d. Right? So that general term is used for us to know what is the term C. Alright? Alright. So aside from this one, no, I'll be erasing. Did you copy already this one? Did you try to screenshot? Try to screenshot already, ha? I will be erasing this one. If ever you could try to have a screenshot, try to have a screenshot. No? Alright, so we will, so that we will be free. Alright, so, so I'll be trying to send the PPT. Would it be possible to you? So I'll be sending the PPT like this first quarter. No. So in the second quarter, let us see. No. So so that we could have this uh, easy access for the things that we discussed. All right. So while in geometric sequence, no, we discussed that kind of general term in arithmetic series. I just reviewed that one, because it's already tackled. No, I already showed that one. So here in geometric sequence, now we seek the first three terms of the sequence having this formula. All right. So this is the general term of these three sequence. Now, if you will notice, all right. So we have a sub n is equal to 2n raised to 2, no? So, it is used in finite sequence naman, no? So, if we say infinite, we tend to have a sub n, no? And it's still continuous. While infinite, I'm sorry, while finite sequence, no? If we are to tackle finite sequence, we have this set of n number. Okay? Alright, so I'll be are you done copying for those who are copying? For those who wants to copy, please take a screenshot to the passage. I will be teaching you how to screenshot shortcut. Maybe aside from print screen, you could press Windows Shift S in your laptop or desktop. In case you are using your desktop, no? Windows Shift S. But if you don't have Windows 10, maybe you could have your sneaking tool. Alright? Okay, so aside from that one, Nat, still copying. Kate, Abigail, is it fine already? Nat, Nathaniel, Abigail, Kate, Angel, is it fine already? Alright, so Nathaniel, still copying? Alright, so we're done. Alright, so a sequence is geometric. Alright, if the ratios, alright, take note of the ratios are ratios of consecutive terms are just the same. No, so there are times that you could see like uh, 5, 5, 10, 20, I'm sorry, 20, like that one. But they are, you have, you could see the ratios, but it is also the same as arithmetic, no? If we have arithmetic, there is difference, no? And we tend to say it is arithmetic if the difference are common to each other, no? In the case of geometric, it is just similar to arithmetic. The ratios are just the same or common to each other. Then, therefore, the sequence is geometric. Alright, so let us have this example now. So, we have 2, 8, 32, 128, 512. Alright, so for this, we could see that it is geometric. Alright, so knowing why, we have the common difference of 4. Alright. Alright, so common difference, common ratio of 4. I'm sorry. Alright, so we could say that it is geometric sequence. Alright, if the common ratio is, if the ratio of in between of the terms are common, no? So again, we could say that it is geometric, alright, if the ratios between the terms are common to each other or similar, alright. So we have the common ratio of 4, alright. So if we have the formula in arithmetic, what is the formula in getting a common difference? We have the formula of difference is equal to a sub 2 minus a sub 1. Alright, so we have that one now. So in our case, what are we going to do is, if you will remember, in the first presentation that I showed to you, we have ratio, no? A sub 2 a sub 2 all over a sub 1, or a sub 2 divided by a sub 1. So I want you to take down notes of this one. No? So it is really important for us because it will be shown to the exam. Alright? Okay. So aside from this one, no? So in order for us to know or to see what is the common ratio, we have this formula. Alright. So in arithmetic, we have the n term, no, which is a sub n is equal to a sub 1 plus the quantity of n minus 1 times the difference. But in geometry, we have the n term. This is the formula for the nth term of geometric sequence. Alright, so I want you to take note of the formulas, no? So, the one that I said yesterday, mabubuhay ka sa math kung meron ka laging formula. you would you will be alive in math if you have the formulas, you have the process of computation, no? So the basic fundamentals, those are the basic fundamentals. You cannot withstand the difficulty if you don't have those fundamentals. All right. So you have the formula of geometric sequence. All right. So which we know already that a sub n is the the value of the term that it is missing. No, a sub n is the value that we are to find, and a sub 1 is the first term, where r, right? So r is the common ratio, no, and n is the term number again. So we have this example. So this is the first term, the common ratio, which is 75 divided by 15. All right. So we have 5, which is r, and what do you call this one? We have the n. How are we going to find n? All right. So if you will notice, no, we have a sub n is equal to a sub 1 times r raised to n minus 1. All right. So if we are to find that one, we have 15. Alright, so 15 here. 15. What is our common ratio? It will be R times n minus 1. Alright, so if you will notice, we don't have still the n. But the thing, if we have the term number that is given, we could be able to find what would be the nth term. Alright, so it's just really the same from the uh, discussion with arithmetic theorems. Alright, okay. So let us have this example, no? 10A, 10A, may I ask if I'm going too fast? Am I going too fast? Am I fast? Honest, the honest one. Can you cope up? Aldea, Renz, Ralph, Carl. Hmm. Am I fast? Maybe you're not coping up already. Kindly tell me, ha? Okay. Alright, so let us have, yes po, a little po. Alright, so I'm sorry, sige. I will try to make it a bit slower now, but try to cope with the lesson still, no, and understand. If you don't really know, or if you don't really cope up with the lesson, please tell me ahead so that I will be helping you. Alright, so let us have this example, no? Example, find the nth term. Alright, so we have the nth term. What is our nth term? We have 9. Alright, of the geometric sequence. So it is geometric sequence. Then we know that we have R, which is what is our common ratio. What is the formula of common ratio? We have a sub 2 all over a sub 1. So what is our a sub 1? We have a sub 1, which is, right, 7, 51, 63. So we have a sub 1, a sub 2, right, and a sub 3. So our a sub 2 would be 21, right, over a sub 1, 7. So if we are to find the common ratio of this one, we will be having an answer of 3. No? So we now have common ratio of 3. Alright. So after we got the 3, no? So now we could have our formula, no? So we have our first term, which is 7. So after getting this one, no? We have the formula. Always try. Ito grade 10. Always remember, no? In solving, the one that I used to see or to find when a student is computing or solving, no? Before you solve, do not forget to write the formula first. Alright? So that will be my instruction, even the exams and quizzes, no? Do not, first step is do not forget to write the formula first, if there is a formula. Okay? If there's none, then there is none. But if there is, please write the formula first in order for you to be guided step by step. Okay? Alright, so having this a sub n already, we now substitute all the given things. So we do have a sub 1, which is 7. Okay? And the r, okay, maybe it is the messy already. So we have r, which is this one. So we now have 7 first, right? This one. And times by 3. This is our r. Alright, so raised to n. Okay. So if we are to find this one, alright, so n. Okay. So what we have is n minus 1, I'm sorry. What we have is for a sub n is this one, no? So what we have is n already. We don't have n. We are not yet substituting n. But we know in the given, we already have the given nth term that we are finding, which is 9, no? The one that I write a while ago. So what we have now is, is substitute the nth term or the ninth term, no, to the n. Alright, because that's the one that we are to find. Like in arithmetic sequence as well, no? So after we substitute that one, we minus that one, and we solve that one. So if you are to solve this one, would you mind to give the answer, Gabriel? Biteng? Hmm.
Wait po, I'm not
Alright,
solving.
alright. But in case, would you mind, this is the last step, would you mind to find the answer for this one? Aside from Gabriel Biteng, Antoinette, Antoinette, hmm,
Yes po, sir.
yes po. Would you mind to tell or state our answer? If you have calculator, you could use it already for us to be fast. No? Hmm.
Sir, wait po.
Alright. How about the others? Ren Santos. Did you find it already? Carl, did you try to find it already?
Sir, is it 45,927?
Yes. So our ninth term, thank you for that one, Antoinette. Alright. So thank you, Gab. Yes. So we now have transpose this one. So 3 raised to 8 or 3 to the power of 8, no? Is 6,561. Then we multiply it by 7. Then now we have 45,927. Alright. So our nth term, hello sister. Good morning. So our ninth term is none other than 45,927. Alright. So did you follow? Did you follow the flow on how we deal with finding the nth term? Did you try? Did you follow? All right. So may I ask, Chanel? Chanel, po, was it clear, Chanel? Yes, po. All right. So may I know your part? Was it a bit fast? Uh, a bit confusing?
Ah, sir,
Yes.
I was confused at first po because I didn't understand po the formula, but then it was clear naman po.
All right. So I am hoping, thank you that one channel. No? So I am hoping for everyone as well that we have that concept in mind as well. No, so at first, yes, there is a vague concept that it was presented to us, but in the end, while we are to solve, even in your partner, when we are to solve, try to write it down because writing your problems is 50% of your solution. Always remember that, no? If you have this kind of problems, if we try to write it down, 50% of your solutions is there already. Alright? Alright, so in geometric sequence, let us now proceed for the next slide. Geometric sequence. In a geometric sequence, it is also found by multiplying the previous term by a constant. Constant. Alright, so we have the things that we discussed last time, which is multiplication and division. No, so we have cases like it was multiplied by fraction. No? So we know fraction is similar as well if we convert that one into division, no? Alright, so let us have this example. So we have the examples of 2, 4, 8, 16, 32, 64, and 128. Alright, so what we have here is this sequence. So if you will notice, no, what would be the factor between this sequence? Hmm. All right, so we tend to see this one, no? Wait. So we tend to have a factor of 2, no? So if you will notice, it was multiplied by 2. Okay? So the one that I said a while ago, we have the things are like general term in arithmetic sequence, but we have the rule as well for geometric sequence. All right? All right. So I am hoping that you are writing all the formulas that we have, and once we have the activities, you will be able to answer it already. Alright. Alright, next. So in general, we can write geometric sequence like this term. No? So we have A and AR and AR squared, then AR cubed, then so on. No? So we have now A, which is the first term, R is the common ratio, and applying those things, no, we could have the rule of A sub n is equal to AR raised to n minus 1. So again, what's the difference to the formula of this one and this right, huh? And this one? So if you were to find, all right, what did you notice? Hmm. All right. So we use this one, huh? So we use n minus 1 because AR is 0. If you will notice, all right. So we have AR, all right. Well, all right. So if we have AR raised to 0, we have the first term. All right. Okay. All right. So in geometric sequence as well, for each sequence, if it's geometric, we are to find the common ratio. All right. So I will be calling some names. We have, let us have number 1 for Nathaniel Santos, number 2, Carl Leal, number 3, Joshua Dale. All right. So number 1, what would be the answer? What would be the common ratio? Just to find the common ratio. Yes, po.
Is it 4 po?
Yes, po. Alright, so it is correct. So, um, is it geometric or not? Yes, it is. Right? Alright, so how about number 2, Harleyan? So we have 1, 10, 100, and 1,000.
10 po.
It is 10. So is it geometric or not?
It's geometric po.
So it is geometric, and the common ratio is 10. Alright, so for number 3, Joshua Day, so may I ask you, what would be the answer? Is it geometric or not? And what would be the common ratio?
-1 po.
Alright, so -1. Alright, that would be the common ratio. So, would you say it's geometric or not?
Geometric po.
Yes, so it is geometric. So how about Sarah Denise? Would you mind to tell what would be the fourth one? Go. Yes, po. Go.
I don't know po eh.
Oh, would you mind to help Sarah? Would anybody want to help? Sarah, would you mind to call somebody else? Go, Sarah. Within the girls. Even their camera is off or on, whatsoever. Go.
I would call ano po, Kate Angel.
Angel, go. Go, Angel.
It's not common Hello, sir. It's
Yeah.
not common ratio po eh. It's -4. That's
Again,
common.
again.
For me, sir, it's not a common ratio. It's a common
Okay.
difference.
Common difference. Why?
-4.
Why?
It's
Try to explain. It's fine. It's fine. It's fine. It's fine. So it is not.
yes, sir. Kasi when we're getting the common ratio, it's that a sub 2 divided by a sub 1. 16 divided by 20 is 0.8.
Mhm.
It
All right.
doesn't add up when it
All
continues.
right. So thank you for that one, Kate. No. So as we see, no, as we saw this sequence, no, we tend to have a sequence of arithmetic, and if you will notice, this has a common difference, which is 4, a negative 4. Okay, so we have negative 4, negative 4, negative 4, and you know it already that if you will notice, it is descending. Yes, it is descending. But if you will notice, it has the common difference, no, and not the ratio. So it is not a geometric sequence. All right, so let us try this one. No? Write the explicit rule for this sequence. Now, so let us try to start with the formula. So always remember not to skip with the formula. So in writing the explicit rule, no, for this sequence would be starting for the formula. What will be the formula? First is a sub n is equal to AR times A times ratio or common ratio raised to n minus 1. Alright, so let's have the first term. Alright, so the first term would be 3. I'm sorry ha, because in this one, we doesn't have 1. It should be A sub 1. Alright, so A sub 1 would be the first term. Alright, so the ratio or common ratio of this sequence would be 2. Okay, so for this one, the rule would be what? Please wait, there is something. Then a Banyares. Why Banyares just now? Would you mind to tell Banyares that I will not be uh, accepting him for this day? Ha? Because it's too late already. For this class, would you mind to tell me if I will accept or not? J- No, I'm just asking you. Are we going to accept him or not? Just chat on the comment section for the majority, so that I will not be biased. I will be asking you, are we going to accept him or not? Chat on the comment section. 10A. Alright, so tell him to rejoin again. Sige, accept natin. Hindi, umalis siya. Alright, so again, for this is, alright, Banyares. Banyares, would you mind to tell me why you're just now? Roy, Roy, yes, would you mind to open your mic and then tell me why just now? Just to open your mic so that our conversation would be quick. No, because I will not tolerate like this one. If all 10A students will be entering like 20 minutes before the class ends, basta ako nagturo. Okay? Alright. So now, please, students, do not have this kind of habit, ha? Alright. So again, we have to make this sequence with the explicit rule, with starting with the formula, which is this one. No. So having this one, what are we to find is the rule itself. All right, so when we have this given already, what are we going to do is to substitute all the given. All right, so that will be the explicit rule. All right, so operations. All right, so it is stated that we would take care of exponents before you multiply it. You know it already in PEMDAS, no? All right, so having this one, all right, so this is the explicit rule already, no? But if I were ask you, or if I ask you to find the 12 terms of the sequence, what are we going to do? So we now have the values of n. So what are we going to do is substitute the givens. All right. So substituting by the givens would be all right. So after substituting that one, so you know it already like how to substitute. No, we now have the value of 12, which is 12 here, 12 there. All right. So after substituting that one, we now have the value of 11. No, because we subtract the 1 to 12. All right. So now we have 11. What are we going to do is to find this answer. No. So in PEMDAS, parentheses, exponents, multiplication, division. All right. We now have 2048 times 3. Then therefore, our a sub n, it's not exa. Let us try to tell that it is x because it is for the last part for the substitution. But I will still consider that one as a sub n. All right. So we now have 6144. All right. So was it clear? So it's like repeating and repeating, no? But the only thing that was changed is the formula, no? But the process in getting the answer in the nth term would be just the same. The only thing is the formula. Okay. All right. So before we proceed for the geometric series, no, 10A, I would like you to look at the screen. No, I would be teaching you something that what do you call this one? Uh, it is something related to arithmetic series sequence. No, so in arithmetic sequence, let us just go back a bit. No, so in arithmetic sequence, we have a sub n is equal to a sub 1 plus n minus 1 times d, right? So we also have this thing that is called as arithmetic mean. Arithmetic mean. Mean as in yung gitna. Alright, so mean or the average. For example, you have the values of uh, what's it called this one? 1, 5. I'm sorry. 1, 5, 9. So if you have that sequence, how are you going to find the fourth term or the second term? All right. So or you are to find the second term and the fourth term. All right. So what are you going to do there is if we say mean, try to take note of this one na. If we have the mean, arithmetic mean, AM. All right. If we have the arithmetic mean or A sub x, all right, we have the values of this one. So let us try to find uh, like two terms between this missing piece. No, so the missing term would be between the first term, and the third term. So let us have a sub 1 plus a sub 3. All right. So the all over 2. So what are we going to do here is in order for us to find the a sub 2 is equal to a sub 1 plus a sub 3 all over 2. All right. So if we are to find the a sub 1, we have 1 plus a sub 3 would be 5. All right. So 5 all over 2. So once we have that one, we are to add this one, and we will be having an answer of 6 divided by 2, which is 3. So we have now the second term, which is 3. Right? So it's up to you if in that case we are going to find the fourth term using the nth term formula. No, but in our case, if that's the case, the only missing is the between of these two terms. What are you going to do is to find the mean as well. So and for us to find the fourth term, which is a sub 3 plus a sub 5. All right, so all over 2. Okay, so after that one, we then now substitute this is 5 plus 9 all over 2. So once we add this 5 and 9, we got 14 over 2, which turns out to be 7. So the mean for this sequence would be 13579. So did you get how arithmetic works? Arithmetic mean works. So it's just easy now. We just add the two terms that is between the term missing, then we divide it by 2. All right? Okay, so for the geometric series, no? So let us have this. No? So we have the summation notation. Um, did you watch the summation notation in our Google Classroom? Did you try to watch? So the summation notation is in our Google Classroom. If I'm not mistaken, it's your section now. So we have the summation notation. Then we have these parts, no? So it's like the same as arithmetic sequence, no? So we have the upper limit and the lower limit. So if we have I, it is the index or the terms between uh, lower limits or the I is commonly used. This is general. This is general. I is commonly used for the terms between I'm sorry. What do you call this one? Um, forget already about index. Well, anyways, index of summation, we are to have this index for each term. No? So when we have this sequence, no, and when we add the sequence, we tend to have the series as well. No, so in arithmetic, once we have um, series, we tend to find the sum. Okay, from the sequence, when we sum it or when we find the sum, we tend to find the it is I'm sorry again. If you have sequence in front of us, when we tend to find the sum, we tend to have the series itself. No, it's like in arithmetic progression, when we are to find the sum, then it is now a series due to its summation. Okay? Ibig sabihin, pag inad natin ang sequence, matik yun, series. Okay? Alright, so let us have this kind of example. So if we will notice, so let us have the term number for 4. Okay? So if you will see, no, if you will see the index, it has the value of 1, no? It has the value of 1, alright? So after that one, if you will notice, the index is just one step ahead. Alright, so that's the one that I'm saying. It's like, it's out of my terms eh. Like yung, what do you call this one? I forgot. I will try to remember that one. So, in index, if you will notice, no, if we have n is equal to 1, as you will see, as the n progresses in each term, it is added by 1. Alright, so that's how, that is somehow uh, a bit near to my term. I just really forgot. But here, if you say index, if you will notice index, no, there the terms in the exponents, no. So we have for n, no. So the value of the index, whatever would be the value for the index, we could know what would be the next term for the series continuously by adding 1. Okay, so if you can see, starting by 1, which is this one, no? 4 raised to n is equal to 4 raised to 1 because the value of n is 1. Alright? So for the next term, we now progress with because it was added by 1. Always by 1, no? So if you will notice, if we substitute all this series or these terms in this series, we will be having this values, no? And if we get the sum of this one, we tend to have this value. Alright, so I will be stopping this lesson already for this slide, so it's already 8:30. So we'll be continuing this geometric series for the next meeting, and I hope for the sequence, you know it already. It's just a arithmetic sequence. So there. May I request to everyone to open the camera and let us have the photo opportunity already. Alright. Alright. So let's have our picture in 3, 2, 1. Smile. Alright, so the usual one, before we leave, please type 1 in the comment section and you may now proceed to your next class. Thank you. Great time.